So welcome. This is what we call the Advanced Manufacturing Lab. It actually houses Professor Xiaoshan Li and my facilities. We share the space. This was the machine shop space in the original building. When it was renovated and things moved around, we were lucky enough to get this space. The activities in here are split up a little bit. In here, we have laser-based manufacturing work that both of us do. And I will let Madhu, one of the grad students, briefly talk about micro laser polishing work that Professor Li, Neil Duffy, and I work on together, and he's doing for his research. We also do micro end milling work. Here's a micro end milling machine that we use. Chris will talk briefly about the diamond coating. We grow or synthesize our own nanocrystalline diamond coatings using chemical vapor deposition over here. And then Professor Li and/or his student will talk about some very exciting nanocomposite work that he's working on.
Hello everyone. So as Professor Fefrikon said, I basically do my research work on this table, right? So the basic setup is we are trying to use a laser to melt the upper layer of a surface at micro level so that we can smoothen the irregular surface features on that, right? Right now we have a Li laser. It's an Nd:YAG laser. It's about 1064 nanometers wavelength. Right? We pulse it at about 300 nanoseconds to 650 nanoseconds. So basically that's the pulse width of the laser. You just see an optic system which just guides the beam into the scannet. It's a very high-speed scannet. Basically has a 2-axis mirrors inside, galvanometers, which basically direct the path of the laser beam onto the sample. On a Z stage here, where we can actually adjust the focus, the distance from the focus on the system. We also have the facility of an argon shielding so that there is no oxide formation on the samples that we use.
Professor Xiaoshan Li will talk about his micro-nano sensors that he creates and embeds in tooling, which is very, very interesting and relevant to micro-manufacturing.
Yeah, thank you and welcome to our lab. So we have been working on that field of micro-nano sensors for process monitoring and control. Martin also one of the collaborators right now. So we have been working on micro-nano sensors, try to utilize the micro-nano sensor to harsh engineering environments, such as manufacturing process. Because a lot of micro-nano sensors utilized in electronics industry or clean environment, right? So all the sensors that are successful, very good response, but the one shortcoming they always come up is they cannot survive high temperature. They cannot survive in very harsh, very abrasive environment like manufacturing, right? So normally when you talk about micro-nano sensors in the silicon wafer or computer chips, when you talk about high temperature, they say 125 degrees Celsius is the temperature limit they can go. But for us, for manufacturing guys, we regularly cutting 600, 800, 1000 degrees Celsius all the time. Right? The sensor cannot survive that. So that's why we think about to integrate thin film micro-nano sensor to the manufacturing process. And the one strategy to make them successful to embed it, because any surface exposed the thin film sensors will get killed, right? Will get killed very quickly by the process. And if we embed into the materials, so-called structurally integrate micro-nano sensors, right, to the structure like we did, you can see later on, you can see all the sensors embed to metal or to the ceramic toolings, like we also have here is before the embedding sensors and after embedding. So this one can use as cutting edge, right? The sensor very close to the tool workpiece interface. And we really can get our sensor as close as 20 micrometers away from the cutting edge. Like traditionally, the best in the world, you can get into about 500 microns. Okay, so because you get less than 500 microns, your sensor gets too noisy. It just cannot function well. And our sensor, just recently we demonstrate we can do that.